Hi, this is Algebra 1, Module 6, Lesson 4, Practice Problems. We are going to practice finding slope, and it says we need to, excuse me, use our answer to indicate which line is the steepest. Well, to find slope, we want to um, subtract our coordinates. So I like to go this way, 17 minus 7 over, then subtract my y's. -5 minus -3. So that would be 10 over plus a positive, -3. So that is 2. So this one is 5. Negative, -5, -2 in there. All right, let's do this one. -3 minus -37 over 4 minus 12. So plus a positive, that would be a positive 34. 4 minus 12 would be 8, -8, which if we simplify this is 17 over 4 or -4.25. Okay. 3 is 40 minus -24 over 21 minus a -11. So minus a negative is, that's 64. 21 minus a negative, it'd be 32. 64 divides 32 twice. Go ahead and just circle these answers in a different color so I can see them easier. All right, and our last one, -40 minus a -75 over -15 minus 55. So double negative, that gives me 35 over, now I'm getting farther into negative, so 55 plus 15 is 70. And so that is actually a -70, so -1/2. So then my steepest slope, um, steepest positive total would be a 2, but 5 is steeper than any of those, than 2, half, or 4.25. So that number one's -5 would be my steepest slope, one that's changing the fastest. All right. Now we're going to look at perimeters and areas, very similar to what we did with this rabbit run. Adam and his brother are responsible for feeding their horses. In the spring and summer, the horses graze in unfenced pasture. The brothers have erected a portable fence to corral the horses in a grazing area. Each day, the horses eat all of the grass inside the fence. Then the boys move it to a new area where the grass is long and green. The porta fence consists of 16 separate pieces of fencing, each 10 feet long. The brothers have always arranged the fence in a long rectangle with one length of fence on each end and 7 pieces on each side, making the grazing area 700 square feet. Adam has learned in his math class that a rectangle can have the same perimeter but different areas. He's beginning to wonder if he can make his daily job easier by rearranging the fence so that the horses have a bigger grazing area. He begins by making a table of values. He lists all the possible areas of a rectangle with a perimeter of 160 feet, while keeping in mind that he is restricted by the length of his fencing units. He realizes that a rectangle that is oriented horizontally in the pasture will cover a different section of grass than one that is orientated vertically. So he's considering the two rectangles as different in his table. So we need to use this information to answer questions 5 through 9. Okay, so fill in Adam's table with all of the arrangements for the fence. First one is done for us. So length and facing, because he has 16 pieces. So half of it would be 8, right? Like we did last time, length and width would be half of the perimeter. So if he has 1 unit in length and 7 in for width, then that's 10 feet because each one is 10 feet. Okay, so let's use a text box in here. So here, if he has 2 units, then what's left is 6 units, which means his length is 20 feet. His width, so 6 units would be 60 feet. And so 60 times 20 is 1,200 feet squared. All right, let's try it with 3. So 3 units there would be 5 units because we need 8 total. So that means this one would be 30 feet. This one would be 50 feet. And so length times width in this case is 30 times 50 is 1,500 feet. All right, let's keep going. This one is so 4 units and 4 units. Actually, just going to go ahead and do this one down. 3 units. This one would be 2 units. This one would be a unit. Okay, so 4 and 4, these would both be 40 feet. This one would be 40 feet. 40 times 40 is 1,600 feet squared. 5 and 3, so this is 50 feet. This one would be, come on, click for me, 30 feet. 50 times 30, 1,500 feet. Look what I'm noticing. It's still the same area. It's just one's horizontal, one's vertical, right? So it's going to be slightly different that way. So here we have 60 feet for that one and 20 feet. 60 times 20 is, get it to click. Doing that before. Come on. There we go. 1,200. Again. Feet squared. Adjust this one since it's kind of in the way. And then 7 and 1 again. So this one's 70 feet. This one is 10 feet. And so 70 times 10. It's not clicking. 700 feet squared. All right, so we've got our table filled out. So we've got some various measurements in here. So it's a little crazy trying to get everything to click where it needs to be able to see them better. It's kind of driving me nuts to have them all over the place. All right, discuss Adam's finding. Explain how you rearrange the sections of the porta fence so that Adam will be able to do less work. So it looks to me like he is going to really want this one right here, the 1,600 square feet, because that's going to give him the biggest area and he'll have to do less work. So Adam would do best with a 40 by a 40 foot, put our labels in there, 40 foot by 40 foot square. It's the largest area. All right, to make a graph of Adam's investigation, let the length be the independent and area be the deep. Label the scale. So let's go ahead and just do this one as right on here because we don't need any negatives. We can't have any negative fence. So I'm just going to go ahead and do here. And this is length, because that's the independent. This one is area. Okay, so area had to get up to 1600. So let's just go write this slightly different. Let's go area in hundreds. So then I can just kind of count on there. So if I go by ones, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Good. I can get it. 5, 10, 15. And our length had to go all the way to 7, right? Yep, 7. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, so when I go ahead to graph this, 1 unit was 700 feet. So 1 and 700. And then 2 and 1200. If I can, no, can't quite fit them both on here. 2 and 1200, 11, 12. It's nice I can be accurate on these because of the how I was able to count. 3 is 15. 3 is 15. 4 was 16. And then it's just going to be the same on the other side, right? Because opposites multiplying are the same. So if I had 8 in one direction, it would be 0 on there. So make a graph. I'm going to go ahead and connect it so I can see this shape on here. All right, what is the shape of your graph? It is a parabola. Parabola. Arch, since it's upside down on that one. And 9, explain what makes this function be quadratic. Well, it is a parabola. So it's quadratic. We could also look up here for second differences. If I looked in here, let's go ahead and just kind of take a look at that. So these two are 500. These are 300. This one is 100. And here again, we have 100. And then this one is 300. And this one is 500. So in between these are 200. And actually, if I went down to negatives, that would be, because that's minus 100. So 100 to a minus 100 is 200. 200 apart. So I could also mention that the second difference is constant. All right, next ones. So we're looking at our graphs. We are looking to see which function is changing faster. So it has a steeper slope. So in this case, f of x is steeper. So that would be our one that's changing faster. In looking at this one, it looks like this one's got a steeper slope. And it's hard to read it on here, but I believe it is d of x. Here, this guy has the steeper slope, and that one looks like m of x. For 13, again, I'm kind of looking for the one that's going faster. And if you notice, this guy is eventually going to cross. It's not quite there yet, but he's really close. So that means r of x is actually steeper. In this case, which one is getting faster quicker? Well, f of x in that one. And then here, they're both going small, but then p of x is my quicker one there. All right. And now here, examine the graph to left from 0 to 1. So if I go from 0 to 1, which graph do you think is growing faster? Well, looks like this top one. So that is s of x. Now, if we look at the graph from 2 to 3, which one is growing faster? Well, looking at that, R of x actually gained more of a line than S of x did. So that means R of x is actually growing faster in that interval. All right, I believe that is it for these practice problems. Thanks for joining us, and we'll see you next time.